have trouble with this part.
I think all you need to do is
There
find
we
the
go.
little,
Okay,
yep,
okay.
screen.
All right, well, customary welcome again. Welcome. This is What's Up over Edmonton for September 2020. The whole idea of this was when the Queen Elizabeth Planetarium opens, it was supposed to open in June, but COVID has thrown everything out of kilter. We would have live sessions where we would actually be in the QEP on Wednesday nights doing programming, and this bit would be on the first Wednesday of the month. So, which is why we do it via Zoom on the first Wednesday of the month. Someday, COVID will pass, and we will actually do this live, and we'll see what happens. Most of the information I use comes out of the RASC Observer's Handbook. It's a wealth of information with more information than you could ever want, I guess is one way to put it. It covers just about all aspects of amateur astronomy and in some cases professional astronomy. So, what are some of the highlights in September? I call this one 5 Planets Before Midnight. So, right now in September, we have dark skies with reasonable weather. When I volunteered at our observatory, which I hope to do eventually when we restart our programming, I would always tell people to come to the observatory in September and October. These are to the people that came in summer when the sun wasn't setting till 10 o'clock. Come in September and October because it's still pretty warm. The skies get dark fairly early, and we can actually show you some neat stuff. So at sundown, Jupiter and Saturn are high in the south. Well, high for reasonably high, I guess. High in the evening, early evening sky. Mars is getting brighter and brighter. Last month it was, at this time at the beginning of August, it was rising at midnight. Now it's rising at 10 o'clock. So when I go to bed, I look out my window and I can see it glowing in the east. And it's rising earlier and earlier throughout the month, getting brighter and brighter. When it will reach what we call opposition in October, when it will be at its brightest and closest to the Earth for this cycle. If you have a telescope, Uranus and Neptune are also in the evening sky. Neptune is above the horizon at sunset. Uranus rises a little bit later. And we have the equinox on September the 22nd. Times of equal day, equal night, and then after that, the night will be longer than the day. So I will stop sharing this while I switch to my planetarium program. And there we go. Share. Okay. So I set the time for this month to 10:30. If I make it a little earlier, I can make it at 9:30. Sky's not completely dark yet, so we'll go with 10:30. Okay, this is the sky over Edmonton at 10:30. Jupiter and Saturn are almost due south. We have the full moon in the southeast. If you had a telescope, Neptune would be just above it. If you looked at Neptune, it would appear as a small blue disk. Oh, and Uranus, which has risen. Let's see. Today it rose at 10 minutes to 10. So it is above the horizon at 10:30, as is Mars. Now I'm going to advance through the months so you can just see the positions changing here. And we'll just go a day at a time. I'll just go to mid-month. As you can see, the moon is, we'll go to the 15th. Okay, by the 15th, at 10:30, Jupiter is starting to set, and followed by Saturn. Again, a telescopic object is Ceres, the largest of the asteroids. Well, now it's a dwarf planet. It is low in the southeast. You could use the star as a Capricorn, I guess, to find it. There are finder charts available. If you just Google that, you can get a finder chart, and you can find your way to Ceres. I didn't like that. My screen just flickered. Mars and Uranus are in the constellation Pisces. Mars is getting fairly bright. I'm just going to zoom in on Mars just for fun. And if you have a telescope, you can actually, why isn't it zooming? There we go. There. So obviously this is a simulated view, so I'm going to change the timing here a little bit. So if you have a telescope over the course of the night, I don't know if you can see my time display up in the corner there, 11 o'clock. You can actually see these dark features, which are visible right now, actually rotating. Mars's day is a little bit longer than the Earth's. 24 hours and, was it 30 minutes? I can't remember. Anyway, you can actually watch Mars rotate. So I'm just going to stop that and zoom back out. And I'm going to reset my time. Oh. Okay. Okay, now we're going to go advancing to the end of the month. Oh no, I haven't. I didn't reset my timing here. Hang on. We'll clean it up in editing. Okay. So we're on the 16th, 17th. And we go right to the end of the month on the 30th. At 10:30, you can see Jupiter and Saturn are just about setting at 10:30. If I advance the time to, say, 11:30, they're almost gone. So by, let's see, make it just before midnight. By midnight, Jupiter is gone. Saturn is right behind it. But Mars is riding high in the southeast. Just going to reset the time. Okay. So that's the evening sky. I'm going to go to the morning sky now. So it's going to get bright here for a second here. So I reset this. So, and go back to this month. Actually, I should make it for the 3rd because we've already missed the morning of the 2nd. Okay, in the morning sky, we've got the only planet visible right now is Venus. But we have the winter constellations, which I really like, even though it's cold out. I really enjoy the winter sky, and particularly I really like the constellation Orion because there's so much to see in it. There's the, come on, very famous Orion Nebula. Here is the horse heads in here. Oops. I'm having a little trouble here. There we go. It's not very clear. Anyway, there's a lot to see in Orion, trust me. And it's got a number of bright stars. And although I've never seen it with the naked eye, I don't think anyone can, a long exposure showing the whole constellation will show you a whole ring of nebulosity around the constellation. Right now, in the morning sky is a good time if you want to see the International Space Station. It's in the morning sky right now. And if you go to website spotthestation.nasa.gov, it'll give you the times to go out and look for it. It will be something almost as bright as Venus, only it will be moving. And because we're where we are at 53 degrees north latitude, and the space station's orbital inclination is 51.5 degrees, it will always cross through the southern part of the sky. The highest it ever gets in Edmonton is about 63 degrees up, which is pretty high, but it'll always be in the south. And if we advance through to mid, oh, there goes the moon. Okay. Okay, I stopped in the 16th because at this time of year, if you go to a very dark site when the moon isn't in the sky, you will see something called the zodiacal light. And what that is dust in the solar system that the sun is shining on, and it looks like a pyramid coming out of the east, almost going up to the zenith. It's visible around the equinoxes. For the fall equinox, it's visible in the morning. For the spring equinox, it's visible in the evening sky. Oh, geez, I just had a brain fart. Brian May, who is the guitarist for Queen, who also has a PhD in astrophysics, and he wrote his thesis on the zodiacal light. There's a little rock and roll trivia for you. And then as we advance through the night, we notice that Venus is getting a little lower and lower. And here we are on October the 1st. Let's see, I'm just looking at my notes here. Oh, also, I'm just going to go back to the morning or the evening sky again. Oops. 10. The Pleiades is returning, which is one of my favorite star clusters, just because it's so pretty. With our own eye, we can see about 6 stars in it, but through binoculars, you can see a few dozen. With a good telescope, you can see, dozens and dozens and dozens more. It's a cloud of new, freshly minted stars, maybe 1 million, maybe 2 million years old. Back in the 80s, there was a show on PBS called The Great Star Hustler with Jack Horkheimer, and he always equated the arrival of the Pleiades in the fall to the smoke coming out of burning leaves in the fall. And I think that's about it. Have you got anything to add, Alistair?
No, that covers things nicely. One of a slight addition was for in the morning with Venus, it passes quite close to the Beehive star cluster.
Right, okay.
So that would be a really nice binocular view.
Yes. Okay.
Not quite as stunning as Venus and the Pleiades, but it's still a very nice one.
Yeah, we missed that again this year because of the cloud. I got pictures of it approaching the Pleiades, but the days where it was actually passing through the Pleiades, of course, we got clouded out, and we got clouded out 8 years ago. So now I got to wait another 8 years. So what are you gonna do? Okay.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie? with the bite taken out. What do you see when you look at the moon? It follows a path
Okay,
every
so
month of the year.
full moon, even though most calendars say September 2nd, because this is Edmonton, and full moon actually occurred at 1:21 Eastern time on the 2nd, which was 11:21 here. So technically in Edmonton, the full moon was on September the 1st. And this is about the skies over Edmonton. The full moon in September, you might think it's the harvest moon, but the harvest moon is the full moon closest to the equinox. So this time around, it's the full corn moon. It's also known as the yellow leaf moon, the berry ripening moon, and the mate calling moon, which I'm told is relates to moose calls looking for love at this time of year. Third quarter's on September the 10th. The new moon is on September the 17th. And of course, like I said before, if you want to get up early in the morning before the sun comes up, when the sky is still dark and you want to go to a dark site, you can see the zodiacal light then. Of course, when I do that, it'll probably be raining. And September 23rd is first quarter. Our feature for the moon today is the crater Plato. So the Plato is above Mare Imbrium, the Sea of Rains, which is right here. And there's an arrow. This is a picture I took a while back. Plato is a fairly large crater. It's about 101 kilometers across. And most big craters on the moon have a central peak. So, and here's a enlargement of my picture. And there it is again. But Plato doesn't have a central peak because it's full of lava sometime in its past. And they figure it's about 3.84 billion years old, just slightly younger than Mare Imbrium, which is here. There was an outflow of magma from the interior of the moon that flooded the crater. And so there is no central peak, which is very unusual. I mean, this, if you look down here, you can kind of make out in my picture, you can see a little dot there, and that's a central peak of this crater. And as you can see, it's newer, has a higher rim, but it does have a central peak. Oops. And this isn't my picture, obviously. With a fairly large telescope with really good seeing, you can see little craterlets inside Plato where impacts have happened after it has formed. Now,
Jeff, were you going to? Oh, sorry. If you back up to your picture of the moon,
yeah,
yes, that one. No,
the big
yeah. Go in a little more.
Okay.
The next one, yeah, is that you can actually see there's been different episodes of lava flooding in there because they're different colors.
Right. Okay. Yes. Yeah. Plato is a fairly dark crater. It's almost the same color as a Maria. So you can't see it at first quarter. You got to wait little later, maybe about waxing gibbous, it starts to show up, and of course through full, and then the waning gibbous phase, you can see it. Okay. All right. Now, I said in August, because the sky is getting darker, I'm going to talk a little bit about some stuff in the night sky. So I'm going to begin with the summer triangle, which is best seen in the autumn, even though it's called the Summer Triangle. It's not a constellation, it's what we call an asterism, which is something that looks like something, like the Big Dipper isn't a constellation, it's part of a larger constellation, Ursa Major, or the coat hanger, which is an asterism, because it looks kind of like a coat hanger. So we're going to talk about the Summer Triangle, and we're going to specifically talk about the constellation Lyra, which contains the very bright star Vega. At this time of year, it's almost directly overhead. It's quite bright. It's one of the brightest stars in the sky. You can't really miss it. And there it is here. Okay, so there's two things in the constellation Lyra I'm going to talk about. The first one is Epsilon Lyra, right here. And this goes back to my time volunteering at our observatory in the fall. We like to show people Epsilon Lyra because it's got a nickname called the Double Double, because it's not one star. It's not even two stars. It's actually two double stars fairly close together. They're so close together to the naked eye, they look like one star. But through a telescope with good optics, you can actually split these two stars together. And we call it the Double Double. It's not about coffee or anything else. So going back to Lyra, we have the Ring Nebula, and it's down here. And these are both telescopic objects. Obviously, you can't see the Ring Nebula with the naked eye. Now, in a telescope with good seeing, it may look like this. Oops. Or it may look like that, no color at all, depending on the scene and depending on the optics. What the Ring Nebula is what is known as a planetary nebula. It has nothing to do with planets. When William Herschel who discovered Uranus, was looking for more planets, he came across these nebula, which were of similar color to Uranus in his telescope, and named them planetary nebulas. And what they are, they're actually the final act of a star like our sun. In about 5 billion years, our star will run out of fuel in its core, and it will begin to collapse on itself. And that collapse will cause a great amount of pressure to build up, and the helium in the core, because hydrogen fuses into helium, that's what powers it, will start to fuse into oxygen and lithium, and the star will swell up, and it will actually shed layers of itself out into space. And that's what this stuff is. This is gas pushed away, shot off from the sun or the star. As it dies, eventually the star in the center will run out of fuel and shrink into a white dwarf, and then eventually it'll die. And that's the fate of our sun, but it's billions of years in the future. Don't worry about it. Or are there any questions? You just have to unmute yourself if you have a question. Or we could save them all for the end. Okay, hearing none. Other highlights this month. So on the evening of September 5th, going into the morning of the 6th, the Moon and Mars will have a very, very close conjunction. They will be very close to one another. There's nothing special about a conjunction other than they look really neat. Although they appear to be close together, of course, they're nowhere near one another. The Moon is 300,000 kilometers from the Earth, and Mars, even at its closest point, is 36 million miles from here. So they're not close together at all, but they look neat. As the Moon moves through the sky, it will have a conjunction not as close as the one with Mars, but on September the 24th, the next night, it will be next to Saturn. And as I mentioned before, the zodiacal light visible from a dark site in the morning sky. These dates are around the time of new moon. And then we have the equinox on the 22nd, time of equal night and equal day. Now, here is a little graphic showing the Earth traveling around the sun. The Earth is tilted 23.5 degrees on its axis. Right in the summer, we are tilted so the northern hemisphere is facing the sun, which is how we get our summer. In December, the northern hemisphere is facing away from us, so it's winter here. And of course, in the southern hemisphere, it's reverse, so it's summer in December and winter in June. Come around to the 22nd or 23rd of September. The sun angle on the Earth is equal for both hemispheres, and we call that the autumnal equinox. And 6 months later, at the beginning of spring, we have the vernal equinox. And I have a little, if you were out in space watching the Earth turn really fast and everything's flying off, this would look like you would see the Terminator going right down the center of the Earth. Now, in Edmonton, as in other cities, when our city was laid out, it only works in the older part of Edmonton. It doesn't work in the new areas with all the curved roads. But Edmonton was laid out in a grid system. So streets would run north to south, avenues would run east to west, and they were very well surveyed, so they are indeed true north, true south, true east, true west. So knowing this, one of our members, Luca Vanzella, past president of the RASC, stood out in the middle of Jasper Avenue a few years ago on the equinox, and he got what he called Edmonton Henge, with the sun rising between the buildings. I guess it's sort of a similar effect to the solstice in Stonehenge, where the sun shines between two of the stone monoliths there. And Luca is also did another picture where he stood in Ice District and did the same thing a few years later. And I did ask him permission to use this picture, Alistair, so not to worry. Anyway, something I tried this myself in my own neighborhood. Didn't get the exact look I was going for, but yeah, it was pretty close. But nothing as good as Lucas.
Yeah, one of the things that you actually have to account for is for the equinox. That's when the center of the sun is due east, so it actually rises still a little bit to the north.
Okay.
Rising meaning the very top edge of the sun,
right,
going past the horizon, and then the center would be due east and west. But for the henge shots, you actually want it about 2 degrees up so that it comes right at you.
Yeah.
So we don't take them exactly on the equinoxes.
Oh, okay. Well, maybe I'll try again this month. 22nd's on a Monday or Tuesday. Okay. All right. Now we're going to our history in space.
And I have to run off and take a picture of the moon. So have a good evening, and thanks for the presentation tonight. Good night.
Thanks,
everyone.
Alistair. Thank you. Okay. So now this is my space history part. Oops, we'll do that again. Okay, happened this month in space. So what I'm going to talk about, the Perseverance rover is on its way to Mars right now. It's going to be landing in February. Let's flip my page of notes here. And it is the first probe that has been sent to Mars. Well, I guess we could count the European Beagle, but it didn't work. So I'll say it's the first probe the Americans have sent to Mars since Viking in 1976 to look for signs of life on the planet, either current or past. One of the things it's doing, it's going to drill for samples as it drives across the Martian surface. And as it collects these samples, it's going to drop these sample cores along. Now, in this picture, they're all spaced together. They wouldn't be that close together. It would drive a few hundred yards, drill, drop a core, go a little bit further, drill, drop a core. This one's all, you can see a whole bunch of them in this picture. So that's just an artist's conception. And why it's doing that is the plan is sometime in the next 5 or 6 years, NASA, in cooperation with the European Space Agency, is going to send a little rover to land in the area where Perseverance was working. And it's going to pick these cores up and take them to another spacecraft, load them in, and they're going to fire these samples back to Earth. Now, this little rocket doesn't have enough power to get out of the Mars gravity well. It's got enough to get out into orbit. But once in orbit, it will rendezvous with another satellite, which will take the samples and fly back to Earth. Now, we've had a few sample return missions of comet dust, where a probe flew through a comet, opened up its collector, collected some dust, and then returned to Earth. Both the Japanese have done a touch and go on an asteroid, picked up a little bit of soil, and came back to Earth. There's currently an American mission which picked up some soil on an asteroid and is coming back to Earth. But this Mars return mission will be the first one in a long time to escape an object with a lot of gravity, or a planet, or a large moon. So why I'm talking about that, because we'll go back in history 50 years to September 24th, 1970, where the very first sample of another body in space was brought back to Earth by this guy. This is Luna 16, which was launched by the Soviet Union on the 12th of September. It went into orbit around the moon, landed on the 20th. It took a sample, took off on the 21st, and returned to Earth on the 24th. And like I say, it was fairly ambitious. They followed up with 2 other missions, Luna 20 and Luna 24. Luna 16 was a twin of another Luna flight, Luna 50. Now, anyone old enough to be around during the Apollo 11 flight may remember that at the same time Apollo 11 was circling the moon, there was this Russian spacecraft, Luna 15, circling the moon too. And what it was going to do, it was going to land on the moon, pick up some lunar soil, and then fly back to Earth and get back to Earth before Apollo 11 did. And then the Soviet Union would say, look, we went to the moon, we picked up some samples for a fraction of the price. We didn't endanger any people. And we beat the Americans getting pieces of the moon back to Earth. Well, Luna 15 crashed during its landing attempt. There was a lot of political back and forth at the time, I remember, because I'm old enough for that, where they thought maybe Luna 15 was going to try and damage Apollo 11, which I can't see that would even be possible, because I don't think the Soviet Union would want to go to war over something like that. Anyway, so Luna 16 was the first spacecraft to return samples of another body to the Earth. And it was quite a big spacecraft, as you can see. This is the actual spacecraft in testing. I should go back and whoops. this whole section here is for landing. Okay, the return part was this bit here. This would separate and come back to Earth, and the samples were actually in this little ball, which had a heat shield on it to survive re-entry into Earth's atmosphere. So, like I say, it was quite a large spacecraft. Now, I got a little movie that I found on YouTube. It's in Russian, and I edited it down because it's a bit long, but it kind of shows how the whole thing worked. So let's run that here.
Установка. Скорость движения уменьшилась. И под действием лунного притяжения станция Луна-16 становится искусственным спутником Луны. Станция идет на снижение. 20 сентября в 8 часов 18 минут уверенная и точная посадка в море изобилия. В действие вступает грунтозаборное устройство. Грунт взят. Миллионы лет он был частицей Луны, а теперь, заключенный в капсулу, отправится на далекую Землю. Космонавтики с поверхности Луны стартует автоматическая ракета. Ее полет к Земле проходит сначала по гиперболической траектории, а затем по геоцентрическому эллипсу. Отделившись от ракеты, возвращаемый аппарат входит в плотные слои атмосферы. Вот он. Место посадки определено. «24 сентября 1970 года в 8 часов 26 минут по московскому времени, преодолев большие перегрузки, опаленный высокими температурами, приземлился возвращаемый аппарат станции Луна-16, доставивший частицу Луны».
Headline news.
Завершен сложнейший эксперимент.
Yeah, so that's a little movie showing how the Luna 16 and 20 and 24 would work. It's kind of interesting. I like how it has a little beeper making a noise so they can find it easily. So it returned. Let's see here. This is the actual sample it brought back. It brought back 101 grams of lunar material. Luna 20 wasn't so good. It brought back 55 grams. Luna 20, that was in 1972, and in 1976, Luna 24 brought back 170 grams. Just as a comparison, the 6 Apollo missions brought back a total of 382 kilograms of lunar samples. It landed in the Sea of Fertility, which is probably the second of the big areas you would see after New Moon. And this is a picture from the Lunar Reconnaissance Orbiter, and you can see Luna 16's descent stage is still sitting there. So I always mention heavens above because there's lots of good astronomical information. There is also satellite tracking times, the ISS. If there's any bright comets in the sky, it will mention that. And other than that, I will say thank you very much, and If there's any questions, I will try and answer them, and if I can, I'll just make something up. Any questions, you have to unmute yourself. So.
No questions from me, but this was excellent. Thank you.
Oh, well, thank you very much. Anything from Alex or the Parkers? Okay.
Yeah, no questions here either, but thanks for putting this on.
Oh, you're welcome. Well, next month, because September 30th is on a Wednesday, I think I'm going to do this on September the 30th. Because, well, you know, the next Wednesday is the 7th, and a lot of stuff happens between the end of the month and October 7th. So I'm going to do this on September the 30th. Also, I'll remind you, if you're interested, our RASC regular meeting is going to take place on the 14th. It is a Zoom meeting also. We're doing everything on Zoom for the foreseeable future, and it is open to the public. If you want to join us, hear our speaker, listen to us debate money motions. If you're interested in astrophotography, or if you're interested in looking at astrophotography images, we have some very talented people in Edmonton RASC, and they're going to have 2.5 months worth of images that they've taken over the summer. There'll be lots of comet images, I'm sure. And on our Facebook page, I've seen lots of good images of galaxies. There's a fellow that has been taking unbelievably good images of Mars already. I can't believe the quality. 20 years ago, you would say the only way these were taken is by the Hubble Space Telescope. They're just so good, so good. Okay, well, if there isn't anything else, I'll say goodnight and thank you, and we'll see you next time.
Thank you. Have a good night.
Yes, you too.
Starry night. Paint your palette blue and gray. Look out on a summer's day with eyes that know the darkness in my soul. Shadows on the hills. Sketch the trees.